What up, athletes? Welcome to day 2 of this cycle, 9.4.1 day 2. And our EQ is, where's the solution region? Where is the solution region? We talked about this a little bit the other day. Where's the solution region? And we're looking for where's the sweet spot or spots. In other words, where do we find the answers that will satisfy both of these? Problem number 1 and problem number 4 are going to be homework. I'm going to be working out 2 and 3 and kind of show you how to do a little bit of each. So, first of all, for 2, well, you know what I like to do. Excuse me. Where's my triangle? Got my triangle. You know I like my triangle. Make this a little more visible for you guys. Why don't I do this ahead of time? Why do I like to show you on video? Because I just like you to see what I go through. And also I like you to see I never ask you to do anything that I'm not willing to do. If I can't do it, well, that's a problem, right? There was a saying for a while, those who can't teach, and I was like, or those who can do, those who can't teach, and I was like, yeah, that's kind of a cruddy statement. If I can't do it, I shouldn't be able to teach it. In fact, I found out if you can teach it, you can usually do it a lot better. That's really the way it is. That's why sometimes I have students help other students, because if they can teach to them, it really helps them learn it that much more. All right. And you know what? Since I'm going to be doing 4 too, let's go ahead, or 3 too, let's just go ahead and do that. There we go. That's the Y. It's because I'm covering the Y and the X. I might as well label it. Let me label our 5s, right? I like this pen. It's working nice. All right. And let's get to this, because really for this first one, if you're paying attention, so first of all, that's dashed. And so is that one, so we're not even going to worry about that. And graphing these guys, if you're remembering, are very simple to graph. It just says a start value of 2, boom, and a slope of 3, so that means up 3 over 1. 1, 2, 3 over 1, up 3 over 1. Now I'm going to go back a few. Down 3 over 1, down 3 over 1, down 3. Right? Okay. And what kind of a line is it? It said dashed. Needs to go all the way through. And what does it say? Y is less than 3x plus 2. So we're going to go here, and we're going to go down, which means we shade everything down here. Okay. And for our next one, what does it say? Well, maybe I should get a different color pen. Let's see how that works. We're going to color code today? I think we are. Do I have a pen that works though? Yeah, there we go. Sometimes they like poop out on me, you know? Okay, this one is 3x minus 2. So very similar, but it's minus 2. So down, 1, 2. It's still 3x though, so that means it's going to be a parallel line, right? So if we were doing regular systems, these would never cross. But now we're doing solutions of inequalities. That's going to be different, or systems of inequalities. So up 3 over 2, up 3 over 2, or I'm sorry, up 3 over 1. What am I thinking? Up 3 over 1. I said up 3 over 2. What was that? Up 1, 2, 3 over 1. Up 3 over 1. And go down a few. Okay, let's connect these dots. Again, it's supposed to be a dashed line, right? Now this one's a little different though. What does it say? It says y is greater than, so that means I put my pen on the line and go up, and I'm going to shade everything over here now. So really, we've just shaded in this entire box, right? But then don't forget, what's the solution set? The solution set is right in between. That's my solution set. And you need to either darken it or do something to show me that, okay? Highlighter is my favorite way, but I'll let you choose. Okay, embrace it, look at it, love it, but that's how we do it. And this is going to be a problem that's very similar. Both are linear. So I gave you two types of problems today. One type looks like this, and the next type looks like what we did in our last session, where we have one linear and one quadratic. So let's go ahead and just start with the linear, because why not? First of all, it is dashed. And I might as well look at this one and say, hey, it's solid. So now we know the difference. Okay, so for our dashed one right here, start value is 1. And it's the slope of 3/4. Don't let that fool you. That's just up 3 over 4. 1, 2, 3 over 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Boom. We'll go back down a little bit. 1, 2, 3, 1, 2, 3, 4. Yeah. 1, 2, 3, 1, 2, 3, 4. You know, why not? Oh my goodness, I did it. I told you I would do it at some point, and I did it. It's supposed to be dashed. So just mark it dashed. I'll forgive you. I make mistakes too. Okay? All right, there we go. And it says y is less than. So that means I'm going to put my pin on the line and go down. Oh, here we go. Okay. Now our next one's supposed to be solid. Watch me accidentally dash. Watch me dash. Watch me solid. Oh, feel good. There we go. No, nope, nope. Okay, got awkward for me too. Okay. Sometimes in my head, I think things, and I do them in reality. I'm like, that wasn't so good. All right. So first of all, this is quadratics. We got to do our stuff here. So first of all, what's my shape going to be? Notice I left you a lot more room on these ones. My shape, well, it's a positive 2x squared, so the a is positive, so it's going to be up. And then my y-intercept, we know it's going to be at 0, -6, because our c value is -6. My x-intercept is going to be what? I don't know, but we know the y is going to be 0. And what comes next? I'm trying to think. Oh, we're going to find my line of symmetry. And then we're going to use that to find my vertex. Okay, now that we've got everything written down that we need to find. And now that my pen is starting to die. It's because this is a rubber mat on the background right here, and so it pushes down. It makes it hard for some ballpoints. So my vertex is going to be, I just have to write it on a piece of paper on a hard desk if that happens. Okay, I'm going to do my generic rectangle. Why not? May turn out I have to get a sticky note and do the quadratic formula, but that's life. So what do we got? 2x squared minus 6 minus x minus 12x squared up here, which we'll solve this rather quickly because that's just what? -4x and 3x. So -4x and 3x. I'll pull out a -2 and x. 3 times that works, and 2x works. Okay. So I'm going to end up with x minus 2 times 2x plus 3. Is everybody with me so far? Let's go ahead and move this up too so you can see a little better. You know what? We can even zoom in. So normally I would pause it and I don't want to see because there's going to be some challenges when I want you to see what to do. Because in most of these aren't going to work out pretty. We can already see this one is going to have a fraction. So here we go. Equals 0. We know this is just x equals 2. But this one right here, we're going to have to minus 3 minus 3. 2x equals -3. Divided by 2. Divided by 2. It's -3 halves. So what's our x-intercept? And I'm going to call that -1.5. -1.50 and 20. Okay? So then to find my line of symmetry, what do I got to do? I got to add these together and divide by 2. So we're going to have 2 plus negative 1.5 divided by 2. And you can probably do it in your head, but I just don't feel like it this morning. It's morning when I'm recording this, so it's my prerogative. Yeah, stat error. Wow, that's weird. Let's see. I got essentially 2 minus 1.5, right? Because the plus minus makes a minus. Divided by 2. 0.25. So it's going to be at 0.25, which means my x value of my vertex is 0.25. Clearly, I'm going to have to do some estimation, as these are pretty small, and it's supposed to be a quarter of a square. So that means right here at 0.25, about, is going to be a line of symmetry that just goes right next to the x-axis, right? That's fine. And let's see, plug that in, so I'm going to have 2 times 0.25 squared minus 0.25 minus 6. I'm going to do this on the calculator. 2 times 0.25 x squared minus 0.25 minus 6. That's negative 6. Negative 6.125 is what it was. Negative 6.125. Negative 6.125. Which I'm just going to say, hey, that's about negative 6.13. So negative 6.13. Well, there we go. That's not a pretty vertex at all. But that's life. Life happens. So let's put in what we know. We know that the y-intercept is at negative 6. We know that the x-intercepts are negative 1.5, so negative 1, and halfway through, kind of right through that line right there. And 2, 0, so right over here. So it's going to be a pretty narrow, very narrow parabola. We know that the vertex is at negative 0.25, which we already have our line of symmetry drawn, and negative 6.13, so just a little bit below the y-intercept. Everybody see that? Just right next to each other. And we can even reflect that across the line, right? Just need a little nub, and let's draw it. It's supposed to be solid, we know that, so boom. And here's what else I know. It's supposed to be greater than, so I put my pen on the line, draw up. That means I shade everything on the inside. And you know how I do it. Where are they both shaded? Right here. So that's the solution region. All right. So you can see this next one works out a little bit nicer, but that's why I did the ugly one. I wanted you to see it though. Just because it comes out the ugly answers doesn't mean we just got to do a little guesstimation. It's not going to be perfect. Guys, I'm using a triangle I got for free. Pretty sure it's not a precision instrument. I'm using this little graph. I'm using big old pinheads that are bigger than some of the points I got to do. So you just do your best, make it look as nice as possible. If you accidentally make a mistake, mark it. And there we go. So this is how we represent systems of solutions. It's a whole set of them. All right. With that said, peace out. Do the rest for homework.